All right, so good morning. My name's Calvin Potter. I'm your field rep for Lennox out of Nashville. Today we're going to talk about service on
Hey,
all the
Calvin,
different products. Sure.
hold on one second. I just got a text from Sarah saying that they cannot get in session. I forwarded the reminder to the team. Is what's happened since then.
All right, so let's get started then. Good morning, everyone. My name is Calvin Potter. I'm your field rep for Lennox Industries based out of Nashville. This morning we're going to talk about service of equipment. We've been talking about the equipment install and what's a little bit different versus maybe what you've seen out in the field currently. We'll talk a little bit about the 20s and 25s and then the S30, along with I'll go ahead and jump over into the 16 and some of the ML14 Merit Line product that we have, and just really talk about what you need to be aware of out in the field as far as setups and things like that. All right, so first thing I want to talk about is the model number nomenclature on our units. I don't think I went over any of this with anybody, so this was something that Sarah brought up yesterday, and I'd already had it kind of in the service module here ready to go. So I want to take a minute and just kind of go over this real quick with everybody. That way the service team, when they get a chance to look at this, they'll be able to see it as well. But in our product line, our model numbers are pretty uniform now across the board. We've got some older product that's still not quite to this uniform, but we're making it a lot easier. So anything with an ML in it will be our Merit Line product. EL that you see here on the screen is the Elite product, and the SL will be our Signature line. The next nomenclature numbers that you're going to see on here is going to be your SEER rating that the equipment's rated at. The X is for 410A. P is for heat pump. If we had a C here, that'd be for air conditioning. And then the next digit will be how many stages that we have. In this particular scenario, we have one stage, and then we go into our nominal tons, ton and a half in this model, all the way up to 5 ton, and then 230 volts. Then we have some revision numbers on the very end. These are very important. I want to document that right now. As you guys start taking our model numbers and serial numbers and putting into your computer system and documenting everything, make sure that you capture those revision numbers, because when the revision number changes, that means something inside the product changed. And when you get into Lennox Pros and start ordering parts, you can actually look up just that revision number only, so that you don't get multiple parts that might fit your unit. So that's very important to document. Also, our serial numbers are a little different than what you're used to too. So our first 2 digits of our serial number is going to be our plant code, where the unit was built at. Then the next 2 digits will be the year. And then we use a lettering process from A to M for 12 months of the year to designate what month the unit was actually built in. Okay, so an example would be 5809A. That unit would be built in Marshalltown. That's the factory plant for 58. The next digits was 09, so it'd be January of 09, 2009. That unit was built. And that's how we go about that. So a little bit different. I know, some people use the first 2 digits and the first 4 digits and stuff like that. Every manufacturer's got to be a little different. But it's pretty uniform with us across the board. It's, once you get it down, I think it'll be really easy to signify. So we talked a little bit about the S30. You may find some existing equipment out there that's been in Huntsville for a while, and you might see this one on the left here, this iComfort Wi-Fi. This is an old stat that we no longer produce just due to not being able to upgrade it, get it up to speed with Apple HomeKit, Alexa, things like that. The home automation side of it. Our S30 is expandable, and that's really what we've talked about. But I just want to make you aware that the one on the left is also a communicating control that we do not sell anymore. So if you have a warranty issue, maybe an existing a dealer installed it and you guys have the service maintenance on it and it's under warranty as far as the part goes, those are convertible. So if you have an iComfort Wi-Fi still under warranty, you will get an S30 kit to replace it. All right. I want to go back over this just real quick. Make sure that we understand setting on a 20 or 25 or any variable capacity unit. You have to ensure that the compressor is running at full rate. And this is where you do that from the dealer portal inside the control screen. You want to go to the test function and you'll be able to set that from there. That's the only way we can get the 100% capacity up and running. All right, so let's dive into the diagnostic side of things. When you go into the notifications, you're going to have multiple options. You'll have across the top here, you'll have red as a critical alert, which means it's something very serious. And more than likely, it's going to shut the unit down where it won't operate and function based on how many alarms it may have hit and the intensity of the alarm and what damage could be caused from it is how quick we shut it down. Okay. The next one will be warnings. And then you have reminders like filter replacements, UV bulbs, maintenance, things like that. And then the next tab will be info. And it will, give you information about the equipment and things like that. This is all in the dealer side portion of that control that we talked about earlier this week. Pretty common occurrence that I get, quite regular is if you shut the, if you leave the power on the indoor unit on and the outdoor unit off, then it loses communication to the outdoor unit and it's going to throw a code on it. It will automatically reset, but you can just cut it back off, cut the indoor section off and power it back up with the outdoor unit on first, and then it will go away. This usually is done during the tune-up process. I'll get guys that go out and do a service on it, and they'll start shutting, power off because we want everybody to be safe while they're doing a tune-up and stuff and spraying water and stuff. And they'll, turn the outdoor unit off and then go in and so on and so forth. So this code comes up quite regular. I get a phone call probably once a week on this code. So I like to bring that up just because I want to eliminate some of those phone calls from your team. All right, so the next slide here, it's a little bit busy as far as the slide goes, and this is where the service manual really comes in. That app we keep talking about, Lennox Pros, there's actually an error code lookup tool on that app. You can actually put in the error code that the technician's seeing in the field, and it will spit this information out to you. There is, I don't know, 40, 50 something codes on here that are pretty regular that we see on a regular basis that can pop up. And so it gets a little confusing about what's a 426, what's a 427. I'm pretty familiar with most of them that I see on a regular basis, but every once in a while, a technician will call me and say, I need to know what a 215 code is or something. And it's like, well, I ain't seen that in a while, or maybe I've never seen it. And so I'll have to look it up just like anybody else. But, it's in all of our service manuals, but that alarm, that error code lookup tool is very, very helpful in Lennox Pros. I use that all the time. Technician calls me, I pull it up, enter the code, and it spits out the information to me. The 400 codes that we're showing here right now, the 426 to the 431, these are codes that I generally see with refrigeration issues or voltage issues to the unit. If you get one of these error codes here, then one of two things is generally going on. We got some high voltage spikes, or the compressor's not ramping up based on, refrigerant charge and things like that. We've discussed earlier in the week how important that line set selection is from some of this equipment. And this is really where it comes in. So for instance, compressor start failure is a 430, and I see that from time to time. After 10 starts, it's going to go to a 434 code, and it goes into a lockout, so it doesn't start after 10 tries. This happens from time to time when we get too much refrigerant in the system, the line sets too big, things like that. That does come into play. So we've stressed the importance of that. I know you guys are aware of that. I know we also sent over the email and the phone number for applications. Those guys are very quick and very good about getting back to you, about line set selection. So this is one of the charts here that I use on a regular basis with technicians. All right, I want to get into the Smart Hub a little more detail about what it does and how it functions. On the left side here of this screen, this is the control that we send the power from the indoor unit to the outdoor unit, and then to the control here at the Smart Hub, and then the Smart Hub goes to the mag mount, which is where the display screen, the thermostat is actually attached to. So it's a little bit different voltage throughout. We'll have, like we talked about earlier, we'll have R and C, which is your standard 24 volts on the left side of this control. And then we have I plus and I minus, and that's your communication wires, your data communication wires between all the equipment. That's how it talks to each other back and forth. Just like a standard computer does, it sends a signal out, receives information, comes back and says, okay, I'm here, where are you at? That type of thing. Now, when we shift over to the right side, this is where we connect to the mag mount that our display or our thermostat, traditionally how technicians would refer to it, on the wall. We changed to 12 volts DC at that point. All 4 terminals are 12 volts. There's no 24 volts AC involved anymore. So that changes a little bit. And we want to make sure that they understand, or that you understand, that that's what's going on. So we have I plus and I minus, the same terminals that we're used to. It just says plus and minus on the right side, but that's 12 volt DC. And then we communicate as well through the A and B bus through there. And that's how it talks to the display and tells it what's going on. And you would test it with a standard meter. Just make sure that you're on DC. Most of the meters this day and time will auto select, but just in case, I always like to make sure they understand that we're talking about DC voltage. And a lot of this stuff, once we get high voltage converted, we're at DC voltage. Our outdoor fan motor operates that way, the compressor operates that way, and also our communication to our from our Smart Hub to our display operates that way. One thing let me back up here. I want to note here in this picture too, while we're looking at it, you'll notice on the right hand side that we've got plus, minus, and the A and B. And when you look at that, the new hub is actually going to be a little bit different. And so it's the next picture that you get right here. Okay, and this is the new version of the hub. It will be out. It was set to be out earlier this year, but my guess is it may be delayed due to some certain things going on in our nation right now. But the thing I want to note is that plus and minus are separated, and A and B are in the middle. Okay, so when your team starts wiring this up, or if you have a connection issue or a display issue where it's just not seeing a certain piece of equipment, more than likely, if you pick up an air handler or maybe pick up a condenser and then it doesn't really see the display properly, then it's communication. It's going to have some lights blinking on this particular hub and let you know that the display is not communicating. Maybe if you get the air handler to pick up and then the condenser doesn't recognize, then it's usually letting you know that there's some kind of configuration with your wiring. So please don't pay attention to colors necessarily. Just write down what you're using for A and B and plus and minus, and just duplicate that, because when you go back and look at the indoor portion of the mag mount here, they're different. Okay, so if you kind of just put left and outside and inside, and then the two inside, they're not going to wire properly. So please pay attention to that. I think the new version, we're eliminating this actually mag mounts. What we're doing, you'll have a standard base that goes on the wall. They'll have 4 wires with the little lug nuts for the small screwdriver, thermostat screwdrivers, and it will snap in there. That's what's going to happen here fairly soon. Also, on the center of this, on the back of your display, this is a pretty good little symbol here, kind of showing you what's going on. You've got communication, and you got 5 volts DC going through this system. So ground to 5 volts, which is the outside ring and the center ring, you should have 5 volts DC on that display. Okay, and it kind of shows you where they go to on the hub itself, the mag mount that's on the wall. And so you can actually take a meter and test it right there. And then on the back side of your display, it snaps right to that and sends power there. Another thing to note whenever your team is installing these units, if you get an older house that has wavy sheetrock or something other like that, if you torque these down a little too much, you can get some discrepancies in displays. So pay attention to that. Don't torque them too much to where the wall kind of cups the mag mount here, and it doesn't allow those to seat good and get a good display. Another one that's very common that I get is the 436 code. This is for the inverter heatsink code. So, keep this clean. You can spray it off with water. No cleaners, things like that, unless we just get oil stained or something, then we'll use some kind of soap detergent to clean it. But outside of that, it is aluminum. It is sealed through the side back, so you can wash it off. But this is how it keeps everything cool. And anytime we're converting voltage from AC to DC, we're generating a fair amount of heat. So we have to keep that heat sink cool. All right, so we've been talking a little bit about our 3-phase compressor, AC compressor that we feed with DC voltage. And pin number 2 is the common signal, okay? And then we have 1, 3, and 4 are your leads on your compressor for a 3-phase compressor, common start and run that you're used to. Those are each fed individually with equal amount of signal, and it ranges anywhere between 4.5 and 5.5 volts DC. I have seen it a little bit lower than that and just a hair higher than that, depending on the load of the house. But it's gonna fare right in that area right there. And then all 3 of your leads outside of the common signal, they should read very, very similar all the way across all 3. Okay, this is DC voltage again at this point, so make sure your meters are set to that. All right, we're going to talk about our compressor. The Copeland compressor does have an internal relief. It will open around 280 degrees, but we cut that prior to that. We intercepted around 248. It says plus or minus 9 degrees, but I usually see around 250 to 251 in the job site visits that I've been to. And then it's going to reset right around 170, 168, somewhere in that range. And we do that so that we can, number 1, keep the compressor from internally locking out. But number 2, when this top cap here opens and there's heat on top of the compressor and we know it's getting hot, it actually sends a signal to our control. And that's a code. That's one of our alarms that says, hey, the compressor is hot. And it lets you know that. Outside of that, the internal device from Copeland, we cannot, register anything from it. When it comes to vacuum, it's vacuum protected. You cannot pull the system down more than 20 psi. Once you get there, it's going to stop and then do an internal relief on itself, and you'll have to stop the compressor and then recover the remaining amount of refrigerant left in the system. While we're on the compressors, one thing to note, I talked about all 3 leads are going to virtually be the same. Here's your resistance windings across your compressor, and they're all a little different based on the tonnage. But what you'll see here, and I want you to really pay attention and really remember, not necessarily what the number is, but that all 3 are the same. Okay, they're really, really close. And as long as you have resistance across all 3 legs the same, a 3-phase compressor is different in that aspect. It doesn't have a start winding necessarily. So they're all going to be the same as far as resistance goes. Again, we talked about that top cap. This is a 5-strike lockout. If we're getting that hot, we got some issues with refrigerant, something to really pay attention to. Something's going on to cause it, because that's pretty warm on top of that compressor. So the 422 is the code that would open up, and then after 5 strikes, we would go to a 442. And that's some of our codes. You'll notice that there's going to be, this is the first time that it happens, you'll generate one code. And then if it happens multiple times, it's going to generate another code. So that's going to kind of give the technician, when he gets to the home, or you remotely look at this system, which you'll have the right ability to do that with your customers that allow you to remote in. You can actually look at this from your home office and see what's going on. Maybe send Bobby instead of John out to the job because he's a little more familiar with this type of equipment. So it helps you kind of coordinate which technician to send as well. But back to this right here is you can actually look at it and say, okay, well, on this date, we had this occurrence. 2 days later, we had the same occurrence, and it eventually got worse. Something's changed. Filter restricted. We're running high compressor demand, something other like that. The condenser's clogged up. Mr. Homeowner's been out here and he's got his yard clean and he's blowing stuff up against it. And so that's another thing that comes about as well. So anything that's going to raise the top cap of this compressor to get hot, you're going to start seeing a pattern, and that's really how we're going to help diagnose what's going on. The inverter code, the inverter itself has blinking lights. It also can read back to the board. You'll have a different set of codes on the outdoor unit versus what you get inside. There is a conversion tool for that. If you put this in, it's going to tell you in that tool that I told you on Lennox Pros, it will convert that over to what the actual code would be on the control itself, the thermostat. Generally speaking, we don't have any way to generate 3 blinks, 3 light codes. We have 2 lights in the inverter itself, and so it blinks a light and generates a 2-digit code. So we have to convert those differently. Here's kind of a list of them. Again, it's kind of busy overall, but there again, you'll notice that we've got 3-digit codes on the right, and then single digit to 2-digit codes on the left, along with some information about the inverter itself and what it's seeing. This is a tool that I brought up earlier, that what it kind of does. It's a pump down, and what it does within about 3 to 5 seconds, when you flip the switch, it turns the compressor on, it turns the outdoor fan on, and it ramps them both up to 100%. It also kills the signal to the indoor blower and ensures that it's not running. So it's essentially a pump down is what it would be, and you would ball off, your liquid line. Suction line would continue to be open until you pump the refrigerant down to 20 psi, and then it would stop. So you need to be aware of that with set of gauges if you're doing a pump down. But I use this more for diagnostics than what most guys think about. If we're unsure of whether or not the board is communicating or not, or whether or not the compressor will even run, turn the switch on, see if the thing will run. I actually did that yesterday with a customer, and we got the compressor to run. So I knew then it was not a bad compressor, and we was on route to diagnose the compressor bad. So it's a great diagnostic tool, and I use it quite regular. Excuse me. So just walking through the pump down process, I told you what it does. I'm going to kind of cruise past this here. I'll leave it up here just for a second and kind of walk through them. Turn the thermostat to the off position, install a set of gauges on the system. You want to close the service valve so that you can suck the refrigerant down in the suction line. You move the jumper over. 3 seconds of delay on it, the compressor will start and the fan will start 100%. Indoor fan stays off, and then you're going to suck it down until it gets about 20 psi, and then remove the jumper, reclaim the remaining amount of refrigerant. If you have a main control board, every once in a while, I have found that we get a scrambled board for whatever reason. I had 2 all of last year, but it was 2 of them that we had to deal with, and one of them come from the factory as an air conditioner instead of a heat pump, and it worked fine until we got ready to go to heat season. And the technician called me, and that's what the issue was. So all we did was just went in and reprogrammed it and said that tell it what it is. If you do change the main control board, though, you have to reprogram it. it's more than likely going to capture the tonnage properly in the outdoor fan model, but that heat pump and AC, sometimes they don't necessarily recognize that. So you want to make sure that you're aware of that when you do a board change under warranty, that the technician runs through this. There's a 7-segment display outside in the outdoor unit. When you push the buttons on it, the recall button, it will actually come up and we'll walk through 3 or 4 different cycles that's available to you. Okay. If it's programmed, then it's going to accept the programming that is there and it's going to start letting you know what's going on. So it's going to display the outdoor liquid line temperature, outdoor ambient temperature, and what position that it's running in, heat pump or AC. And then the next thing it's going to tell you is what is the capacity that's running at. It might be 53%, and it will let you know what's the compressor running at. So this is also a great diagnostic as well, to be able to push the button and see what's going on. But when you program it, the literature is a little crazy. When I looked at it the first couple times, I seen it myself, and reading through it, it's a little confusing. So if you push the button, it's going to come up and it's going to blink. And when it does, you push and hold it again. Then it starts running through different options. It'll say PT, PU, CU, different options that's in there. Once the option comes up that you need, push and hold again, and then release it, and it'll start running through a menu inside of that. And that's how we get it in the different menus. Hopefully I explained it a little bit better than what the paper says, but it does come with a sheet of paper, and we'll walk you through it. If you have any problems at all, just give me a call. I can walk you through it pretty easily. That's what this whole paper here talks about. Okay, we also have capacity of this unit. So we talked about that. So here on the right hand side, I'm just going to kind of highlight what you might see. You see here that it's got a 12 for a 1 ton, 18 for a 1.5 tons, all the way down to a 5 ton on unit capacity code. And once you get in the system, it's going to let you do multiple things. You'll be able to set the outdoor fan, what it needs to be. It will accept up and down on that fan, so you can actually slow the fan down in certain applications. I'm going to let this kind of record here because this is kind of walking through the steps again, but you're going to have, push the button, and you're going to get the 3 horizontal bars. You push again, enter the mode, and the symbol's going to blink, and then you push and hold. And then it's going to run through the different steps, different options. Like, for instance, if we're on PU, once you get there, you want to stop. And then you'll come down and enter the different models that's available. So there again, in this thing, we see that we have a 2 ton, a 3, a 4, and a 5 heat pump, and then 2 through 5 on the AC. You might get a 29 AC, and it's really a 22, and you just go in and reselect that. Main control board, again, when you push that button, it's going to show you the firmware. It's going to show you what type of unit that you have, unit capacity, what we're running at, and then what the unit code is. Okay, so a 17 would be a 2 ton. We talked about the airflow settings before, but I'm going to kind of touch base again, just real quick. Make sure that you make adjustments on these and where they're located at. They're going to be in the dealer portal of this control, and you go underneath the heat pump. If we had an AC, then you go underneath that side. You can see here on the left we have a furnace selected here in the screen. You would have an air handler if we had a heat pump matchup. 312. This is something that I get quite regular, I guess, if the ductwork's not correct. And I know I've talked enough to the sales team that they're very big in making sure that the ductwork is correct. We all agree that that's the best delivery to the home and giving the customer what they pay for. If you're anything over a 0.8 static pressure, it's going to kick a code to you and tell you that you're out of parameters. It will still allow the system to run within reason, as long as it's not very much more than that, but it will affect the system, and it knows that, and it's going to trigger an alarm to you. an error code. Here's a great example of what not to do. External static pressure too high. You know, we've got dirty coils, dirty filters, registers blocked or closed, return grills that are blocked, and dampers that are closed for zoning type systems. This is a great looking job here. I know this would pass probably about anywhere, right? All right, so the next thing we got that I want to really touch base on, and this is something goes across our product line, okay? We have high pressure and low pressure switches in just everything that we've got. And I want to make note of that because I think it's very important. We've talked about that both expansion valves are indoor and outdoor, and the importance of pulling a vacuum and ensuring that we use filter dryers and things like that to ensure the system is dehydrated properly, and then also that we take, you know, the proper precautions to ensure that it's clean. There is absolutely nowhere for the contaminants to go but right to the screen or right to the TXV. So, you know, if you have contaminants in the system, it's going to flow right to that. So outside of that, we have our pressure switches here, high and low pressure switch, and we do have a 5-strike lockout on our boards. And what that means is if we hit any of these pressure switches, whether it be high or low, 5 times in a given cycle, we're going to lock it out. So if you get out to the job and you look and this system's on lockout, and we're going to talk about what it looks like on the board in just a second, but 590 psi is where it locks out. That's a lot of pressure. Okay, so one thing I want you to be aware of is if it trips 5 times and locks out, it's not a nuisance trip, it's not a shadow. There's something going on. So many times I have technicians that's been out 2 or 3 times and they've had a 590 psi lockout, and they change the board, they change the sensor, they come back, you know, and it's still doing it. They hook their gauges on, and at that time that they're there, they're just running 250, 260 pounds of pressure on the high side, and the low side looks within range. So it's doing something when they're not there, right? And that's why the switches are there to protect the unit when you're not there to monitor it 24/7. That's what it does. Hardly ever do I find in all my years, 20 something years of doing this, have I found a switch actually bad. It does happen, and I have found probably a small handful, I'd say less than 8 in those 20 plus years that was actually bad. They just don't fail. They usually do their job. So that's something I want you to be aware of. If you have something going on, please explore deeper. Give me a call. Let's get involved and figure out what's going on. Okay, it's usually something in defrost if we have a heat pump situation, or if we're in that time of year like right now where we're swapping between heat in the morning for a little while, and then by the end of the day we're in air conditioning mode. That's generally where I see that we have some issues, because at that point it's not real cold, but cool enough that we need some heat in the house, but our coils are, you know, extremely large outdoor. We're gaining a whole lot of BTUs that we have to absorb on the inside. On the low pressure side, it's very much the same thing. We open at 25 psi, and we close at 40 psi. So if we get down that low, there's something going on. So this is my chart again on the 2-stage product, on the variable capacity product. I'm sorry. And so 2 ton will go down to right at 3/4 of a ton. A 3 ton goes down to a 1 ton. 4 ton goes down to 1.6, and a 5 does 2. Again, we got the minimum airflow and the maximum airflow. It's important that we do not oversize this, and I really want to touch base on that on this next slide. This is actually out of Lennox Pros. This is going to be your expanded data chart for your equipment. So if you did TVA type work and things like that, you're familiar with what I'm talking about. And this actually gives us a ratio of what this machine will do. So I pulled this off, kind of screenshotted it. I apologize, it's not real perfect on the slide, but I wanted to illustrate the importance of it. At a 59 degree off to the left, or a 63 degree wet bulb, which is going to be right around when the house is around 50 to 55% humidity, that's about where it's going to fall at with a wet bulb temperature. If you go across on a 75 degree day at low end, let's say I think this is a 3 ton. It is a 3 ton with a 3.5 ton air handler match. So on that low end, we're doing 1 ton, right? So we'd be right around 400 CFM. And if you come across here at 450 CFM, we're doing 100% of sensible. Okay, 100% sensible, zero humidity removal at that point on low stage. Okay, as we get warmer outside, it still continues to be 100%. It gets worse actually. So what I want you to understand is if this unit is running at low capacity at 87, 88, 89 degrees outside because you oversized it, we're doing very little to minimal humidity removal. And that demand in the home continues to rise. And that's really what we're telling a customer. We're trying to make them more comfortable with this machine, and it can actually make it worse. So again, proper load calculations, which I know is very important to HC Blake, and I know that you guys do a great job of that. If you're on the bubble, call me if you want to discuss it. I'm happy to do so. If you're on the bubble, I would make every arrangement to either seal the ductwork up and make it tighter, or add attic insulation or whatever to try to keep that unit. You don't want to go from a 3-ton because we're right on the bubble and go to a 4-ton. It won't function, operate correctly. 95 degrees outside, I do understand the fact that, it does get a little hotter than 95 outside, and you do have customers that want it 72 and not the normal 75, that everybody kind of talks about kind of keeping you there. So you have to obviously evaluate your customer when you're talking to them to see what they like. If a customer likes it 68 degrees inside, then that's a different situation as well, and you have to allow for that. But just understand that as we crank this system up and it's at lower capacity, it's not designed to remove humidity, because essentially when it's cooler outside, there's not any humidity out there. We don't have humidity concerns yet, right? And so we have capacity concerns, and we can run down. So it's very important. I hope this opens your eyes a little bit about what you may see here. Live capacitor test. This is something that I think every technician should know how to do. If you do, then that's great. If you don't, for those that don't, I'm going to walk through it real quick. This is kind of like bench testing a battery. I've got a Subco tester that you can actually clip on to a capacitor, and it sends a 9-volt charge out and sends a reading back and says capacitor is reading X microfarads. And it's fairly accurate overall, but if you start doing a live test on these equipment, you'll find in anybody's equipment, as far as tune-up goes, how many times have someone went out, a technician, in the spring and said the capacitor's good, and by July, August, it's failed? So what happened? Well, was it close or not close? Sometimes they just fail because they get extremely hot. Something's changed, from that standpoint. But sometimes that capacitor was running, when you start putting it under live load, what's it actually reading at that point? That they're weaker at that point. So this is a mathematical calculation. It's been around forever, but it's not really posted throughout our industry very well. So some of you may have been taught this, and that's great. I was fortunate enough someone taught me, and I've used it for years. Be careful. You are dealing with live voltage, but it's basically amps times 2650 divided by the voltage, and that gives you the capacitance of what that capacitor is actually rated at, or what it's reading at that point in time. So let's walk through an example with an actual unit running. With the unit operating at full capacity, we want to check the HERM off the run capacitor. In this example, we're going to get 5.66 volts AC. With the unit still operating, we want to measure the voltage again between HERM and common. In this example, we get 357.5 volts AC. So all we do is just take those two numbers, we take our amp draw of that lead, and we take our voltage of that lead. And I want to back up here just a second too to this slide. Notice that the voltage is always going to be much higher than the 230, 240 volts that you're used to working with. If you notice on the side of a capacitor, it's rated for 370 volts or even 440 volts. And that's the reason why. A lot of times you're going to be running close to that 370. It's not uncommon to see 360, 362, things in that range. And in the old 370 volt capacitors, you're always at almost max level. So it's kind of, like running a car all the time and at full throttle to the floor. Eventually you're going to burn something up. Yeah, it'll run 120 mile an hour, but it's not designed to do it all the time. And so that's why a lot of companies go to 440 volt capacitors. And as an example here, we have one as well in our unit, 440 volt. Then all you do is just plug in the numbers, right? You take your amps times 2650 and divided by the 357.5 voltage. The cap is rated for a 45.5, and you can test each one of those individually. You can test the Herm side, you can test the fan side. In this example here, we come up to be 41.96. So this is generally where I ask, is this capacitor good or bad? And I get some hands that come up and say, well, capacitor's good. Some's going to say it's bad. But plus or minus 5% in our example here on the screen, this capacitor is actually bad. So that's something that I do quite a bit. Run test, load test. It's going to give you a true reading of what that system's doing. All right, we're going to talk a little bit about the defrost control here. The XP16 and up, we talked about it uses the demand defrost, which measures differential temperatures to detect when the system is performing poorly due to ice buildup on the outdoor coil. The control self-calibrates itself when it starts and after each defrost cycle. So it's always learning what's going on. It monitors outdoor ambient temperature, the outdoor coil temperature, and total runtime to determine when defrost is required. Okay, so you'll tend to see a little heavier frost on this system than a normal system. For the first defrost, after the system's first powered up, or in the event that the coil does not clear, the control will revert back to its standard time and temperature operation. After it completes a successful defrost based on the temperature sensors, then it'll start remembering what's going on. Again, remember you're going to have a lot longer runtime, and you're liable to see a little more frost accumulation than normal. But as long as the temperature sensor is saying that we're bringing heat back to the home, then that's what we want to do. So energy efficiency wise, this control can tell if we're putting out the BTUs by the discharge line. All right, so we talked about the sensors that's on here, the coil sensor, the ambient air sensor, and the discharge air sensor. These are 10 ohm sensors, 10K ohms. You use a standard 10K ohm resistance chart to test and see if they're reading properly, or even what they're reading. That's something that I want technicians to understand. You can actually put a temperature probe right beside this sensor, and let's see what it's reading. Okay, if you're a Cooper box, I use a Cooper box. Temperature probe, and I strap it to the line right beside the one that's there, and I'm reading, let's say 67 degrees, and I go over to my 10K ohm chart, then 67 degrees, I should see a resistance rated based on that. And when I measure resistance across that, it should tell me, is it reading the same or not? So I'm big on checking to see what's the sensor actually reading, right? We know it's located in the right place. We know that it's doing its job, but what's it actually reading? Maybe it's out of calibration. I mean, that happens. So we need to know that. Okay. Here's an example of that chart. It is in our service manual, but if you just Google 10K ohm chart, you can pull one up. It's just a thermistor chart's all it is. All right, so filter dryers, I talked about this a little bit yesterday. When you break into the system, you must replace this filter dryer. I think I beat it pretty bad yesterday, so I'm gonna move on from it. Compressor electrical checks on this thing. We have a solenoid on our two-stage compressor, and it is 12 volts DC going to the solenoid. So this device here that you see, it's a plug, but it also has a rectifier built into it. Okay, so we're going to send 24 volts down to it, and then the compressor is going to get 24 volts DC to it to change it over from single stage to two stage. On the XP16 we talked about yesterday, only our 5-ton currently uses the DC voltage and line voltage. It's very much like an X13 motor requiring both high and low voltage to operate. there again, we are talking about DC voltage though on the low end. So this is a 700 RPM on low and 820 on high. And so we're always going to have line voltage. And then we're going to add Y1 and Y2 on our 24 volts DC to trigger and tell the motor what stage we need to be running in. So we just add, we have Y1, and if we wanted a Y2 input, we just add the extra line along with the first line, Y1, and that says we're in high stage. All right, so our standard time and temperature board, all of our other units, including our package heat pumps, use a standard time and temperature control that you're used to out in the field. It's standard time and temperature. We have a quiet shift feature on it from the factory default on this pin jumper number 5. It's in the jumper itself is in place, and that's going to be your delayed defrost, kind of like a quiet shift type of operation. That we have about a 30-second delay between the compressor shutting off and the reversing valve shuttling, and then when it cranks back up, so that you don't get everything happening all at one time and get that big noise. We also have upgraded the board on the Dash 4 models and up. So everything that you guys are going to see out there, we have a built-in temperature sensor on the board. And we did this basically for the package unit. When the package unit first come out, the Dash 1, several years ago, when we converted to the new model that we're talking about, we had some issues on when it was really cold out, that it went into defrost, it would actually kick the low pressure switch. So anything below 15 degrees outdoor ambient temperature, we automatically no longer look at the low pressure switch. Okay, and it's done in a safe manner, because just like low ambient cooling, where we control the outdoor fan motor and the head pressure on it, it's really not even important anymore. There's really no damage that can be caused from it and things like that. So anything below 15 degrees, the board's automatically going to no longer look at the low pressure switch. So if you're running a really cool, really low pressure and heat pump, which is not uncommon, and understand our equipment's installed all the way up in Canada too, so it gets extremely cold in some climates where this equipment's running at. And then the next thing that's changed as well is when we enter defrost mode, we no longer look at that sensor either. Okay, and for the first 10 minutes of run time after defrost cycle is over with, we're still bypassing that temperature, that low pressure sensor. So it's not going to have any nuisance trips due to defrost, and that's what we had on the heat pump control on the package unit. And we changed it from the Dash 1 to Dash 2, and when we did, we relocated another switch, which we'll talk about in another training. But I just want to make you aware of it. This is one universal board across all of our products for time and temperature. It works really well, and it's got some features built into it there. The outdoor coils on all of our equipment, we're converting to quantum aluminum coils. One thing to note about this is on the tube sheets itself, we use aluminum end sheets, so we have the same dissimilar metals. That's one thing I think to note on our products there. It's not going to have galvanized or something like that. Be sure to use water only. No chemicals are allowed on our equipment as far as the aluminum coils are concerned. If we have to use aluminum, have to use a cleaner or something, we want to make sure that it's a cleaner that's pH neutral and is designed for aluminum. There will be some times throughout a life of a unit that you at some point in time will have something that has a leak, and it's going to have refrigerant coming out and oil coming out. It's going to hit the coil, and you have to clean it with something other than just water. But the normal maintenance of this unit is water only. On our time and temperature type of control, this is on a split ML14 unit here, condenser, which I think you guys have some of these in stock. It's going to be located, the defrost sensor is going to be located right at the expansion valve. Okay, this sensor is going to open or close at 42 degrees plus or minus 2 degrees. So anything below 42 degrees outside, whether there's frost in the air, whether there's moisture in the air or not, it will actually close and can go into defrost for a few minutes. It opens at 68 degrees. So what that means is once a defrost is initiated, it's going to keep it in defrost mode for a maximum of 11 minutes. If the sensor does not remove it, the board will automatically remove it out after 11 minutes, or as soon as the sensor reaches 68 degrees, it will terminate defrost and go back into normal heat pump operation. Then at that point, your heaters will stage back down and everything will go back to normal like it was before. Drill and spin technology, we've utilized this in our ML14. We had in the past, it was just kind of a surface mount, drill a hole, stick that equalization tube in there for the expansion valve. And we've done kind of the what they call a drill and spin. It kind of flares that copper out a little bit, gives it more surface area to weld to at the factory instead of just a tube on a tube type situation. So it makes that joint a lot stronger. All right, I know we're going to get into furnaces eventually, so I'm just going to touch base on a couple things. Yesterday we talked about the low voltage wiring, that it has a jumper built in for the O terminal. If you have a heat pump, you have to cut that jumper. We have that also in our furnace control for 2-stage. You have jumpers in there as well. And then D-Hum and iHarmony, which is our zoning control, you'll have to cut that jumper as well. So those are kind of universal across our platform there. If you do a dual fuel with a gas furnace, then of course you'll have to cut the heat pump jumper. And if it's a 2-stage outdoor condenser, you'll have to cut that jumper as well. The air handler is the very same way. Again, we talked about it a little bit yesterday, but I just want to bring it back up. The air handler does have jumpers on it as well. You want to remove this if you're using iHarmony. This is our jumper for W1, W2, and W3. You can individually trigger those heaters to bring on just a little bit as needed, or you can bring them all on at one time. It's entirely up to you. Maybe you just got a 10 kW heater and you want to trigger it all at once. But if you use the iHarmony or zone control, we have that DAT sensor I talked about where it'll actually control the heater and bring on only what's needed. Furnace air control, it comes factory as an A ramp here. We have 4 different ramp profiles. I talked a little bit about that yesterday, about the blower itself is not a normal G-call, is not a normal cooling demand blower. So in this scenario here, on this furnace, is the blower is going to come up and run at 50% air volume for about a half a minute. And then for the next 7.5 minutes, it's going to run at 82% volume. And that's where we have it set at the factory to default. You can adjust that. I had a customer one time that says, I don't want that, made the dealer change it. So we went to D-profile and it runs at 100% compressor demand all the time. Just one of the things that this customer wanted. They didn't like all that lower stuff and just what it was. But we do that for a reason. And that's for that, normal run cycle on this unit is going to be 8 to 10 minutes. And so we want to make sure we can get as much dehumidification done as possible during a given run cycle. Then if the compressor demand is still there after 7.5 minutes, we still have a call for cooling, whether it be 1st stage or 2-stage, then the blower will ramp up to 100%. And then after the demand is over with, it'll come down to 50% air volume for 30 seconds and then shut off.
Hey, Kelvin, I just want to be respectful of everyone on the call's time. We just kind of hit 8 o'clock. Do you have kind of how much we have left?
Yeah, I got about 4 slides left. I think we would have hit an hour right on the money. We just kind of got a little bit of late start there, about 7 minutes.
Perfect. Thank you.
Yep. So I'll speed it up a little bit. I apologize for that. On the furnace control, we talked about this yesterday. Please note that the factory setting on the furnace control is 38% demand of the blower, of the cooling blower. It's operating between 28, 38, 70, and 100% is the options on that. So you want to select that option. Again, this is more for IAQ type control. All right, so I know you had some M30, so just one thing that I get several phone calls on when that M30 first comes up, the little smaller control stat that I think you guys will be selling with the lower end stuff, 16 maybe, and then maybe the 14 for sure. Time zone, which we don't have that problem in Huntsville, we're on Central Time Zone, but I have some guys in East Tennessee that this comes up. Daylight savings time adjustment is on here. Once you set this up, this screen goes away. Okay, you cannot get back to it unless you do a hard reset on it. For whatever reason, that's just the way it is. So my guys in East Tennessee, it's a big deal. All right, we talked about the app a little bit, and we'll move on from these because I know we're running short on time. Okay, any questions?
Yes, sir. This is John McAllister. One quick question. Are Lennox units exclusively made in the United States?
They are not. So our Merit line product is made in Saltillo, Mexico.
What's the closest place that they manufacture Lennox?
Probably Orangeburg, South Carolina.
South Carolina?
Yep.
Okay.
And then we have some coal manufacturing done in Mississippi and Grenada.
Yeah, and to speak to that, when you look at the bulk of your sales, it's going to be equipment made in the U.S.
Yes.
Most of it's from our Marshalltown, Iowa plant.
No, that's good to know. A lot of people like to know that, especially in Alabama, pretty conservative state. So knowing that at least a lot of it's made in the U.S., that helps.
Yeah, so when you look at kind of your guys' sale, that baseline Merit product, that is made in Saltillo, Mexico, but as we kind of move up into Elite and Signature, that's where that's primarily just produced here in the U.S. And that's going to be, call it 80% of your sales right there.
Okay, that's good. Thank you.
Any other questions?